So this is chapter 0.3. We're going to talk about the coordinate geometry. So for coordinate geometry, it means that we have x coordinate and y coordinates for a point, and we will try to draw these two axes, and then we will try to find the distance of points, something like that. So for example, if we have a distance between 2 points on the same horizontal line, then we simply know that the y coordinates are the same. So the difference will be their x coordinates. So if it is a vertical line, then the x coordinates are the same. So the difference will be their y coordinates. Let's say if the larger value of y is 3 and then the smallest value of y is -1, then the distance is 3 and 1 altogether is 4. So the distance between 2 points is like this. And somehow if there are 2 points with different x or y coordinates, they are different, like this, the point A and B, then this straight line, if we want to find the distance between these 2 points, that means the length of this line, then we need to use the Pythagoras theorem. That means we want to find the distance of B and C and A and C, so that we can use the Pythagoras theorem to find the length of AB. And sometimes we need to find the area of a polygon. That means we try to find the length of each side of the polygon and then use the formula for polygon to find the area. And also we need to know about the slope of a straight line. For example, you can see here, this straight line with the left hand side to the right hand side is going upward, then that means the slope of it is a positive slope. If the other line like this, from left to right, is going downward, then the slope is a negative slope. And we were defining the slope m as a y2 minus y1 over h2 minus x1. Of course, you can also change the 2 points at the same time. So that means y1 minus y2, x1 minus x2, that's okay. But you cannot say it's y1 minus y2, and then this one is x2 minus x1, then this is not correct. Okay, so if two lines are parallel, then we will say that the slopes are the same. On the other way around, if the two slopes are the same, then these two lines are parallel. For perpendicular, if the slope of two sides multiplying together is -1, the product is -1, then these two lines are perpendicular. On the other way around, if the two lines are perpendicular, their slope multiplying together equals to -1. And then we have a midpoint formula. Midpoint formula means that if I want to find the midpoint of, let's say, AB, the midpoint called M, how to find the x coordinate and the y coordinate? You can think it as the x is actually the average of x1 and x2. Y is the average of y1 and y2. So if it's the average of it, then you have to add these 2 points. Remember, it is not minus, it's adding 2 points over 2. y1, y2 over 2. So for example, if the x coordinate of this is 1, the x coordinate of this point is 3, you know that finding the x coordinate of M, you should find it as it is 1 plus 3 over 2, not 3 minus 1 and then over 2. So it is actually 4 over 2 is 2, like this. And then the other, we call it the internal point of division. So what is that? That means this time the ratio is not 1 to 1. This is not the midpoint, but maybe on some other ratio, let's say h to k. You can imagine that for this, you show that h to k, let's say it is 2 to 1. So the point P is closer to B than A. Okay, so what it means, if you have 2 to 1, we need to know what is the ratio for that. So this is, in this case, we can say that x is 2 over 3 of x2 plus 1 over 3 of x1. So that means a more ratio, the larger ratio is to multiply x2, and the smaller ratio multiply x1. That means this is more affected by x2. So that means h is 2, k is 1. So you can get something like this. Similarly for y, so it is more affected by the point B, closer to this y2, the coordinates. That's why y2 will multiply a greater number here. And then plus this one is y1 multiplied by a smaller number, the ratio here, and then over the total. is 2 plus 1, something like this. Okay, next part is that we need to learn about the transformation. If this is a coordinate of points, there are various types of transformation, including translation, reflection, and rotation. For translation, that means it moves. It is moving to the left, to the right, upward, or downwards. Say it is to the right. That means this point to the right, the x coordinate plus the certain value here. If this is translated to the left, then this is x minus h by h unit. And it can be moving upward and downward. If it's translate upward, then the y coordinates plus that certain value. And if it is translated downward, the y coordinates, you have to minus that certain value. How about reflection? Reflection is about reflecting along about the x-axis or y-axis or some other axis or some other lines. Say in this case, it is reflected about the x-axis. That means originally the point is up, okay, up above this x-axis. Reflecting will put it downward below the x-axis, and the distance between these axes are the same. So that means originally it is y, coordinate is y, that means this length is y. Then translating with reflecting about the x-axis, then this distance is also y. But it is below the x-axis, that's why the y coordinate is minus y. At the same time, it can be reflected about the y-axis. Y-axis is here. So it is from left to right or right to left. The distance are the same. So it is originally is x, then it becomes minus x. Or on the other way around, if it is originally minus x, reflected about the y-axis, it becomes x. And reflection can be on other axes of reflection like this. So for example, if the distance between this point to this line is k units, you can count one more time below this line, k units below this line. So that means the new y coordinate will be y minus 1k, 2k, y minus 2k. It can be the same like this. This is reflected also about the horizontal line, but this is like the horizontal line is above this point. So y is originally here, and k units, altogether 2k units. So above it, the y coordinate will become y plus 2k. And also it can be reflected about a vertical line. So if it is reflected about a vertical line like this, so this is x equal to something. Now originally this is y equal to something, this is x equal to something. Then if this is h unit, and originally the point is here, reflect about this, the x coordinates becomes x minus 2h. And originally it is on the left hand side of this axis of reflection, and then reflect about this axis of reflection, and the distance is h units, that altogether 2h units, so x plus 2h. So the other concept is rotation. Rotation, that means you have to think about the point rotate. Most likely you will see 90 degrees, 180 degrees, and 270 degrees. So how do I know about it? Originally, we usually think about a point with two really different values, let's say 5 and 1. So this is a 5 and 1. Then how would you rotate it? Let's say it is rotated anti-clockwise. Originally, I would think that this is the original point. You have an arm like this or arrow like this. And then you want to move 90 degrees. Okay, move 90 degrees. That means this blue line, the longer side is here, and the shorter side is here. This distance is 5. This distance is 1. So the new point here, let's say this is original A and then become A prime. Then the new coordinates will be -1 and 5. Now you can see when rotating 90 degrees, x and y coordinates, the value, the numerical value will get interchanged. And you have to think about which quadrant is it in. So the positive and negative sign, you have to consider it and consider it. And also, if more 90 degree more, then you can from this side, you can think about it. It becomes something like this here, and then 5 units, and then 1 unit like this. The new point will be here. Then the coordinate of this is -5 and -1. So on and so on. Lastly, if we rotated 90 degrees more, then this length is 5, this is 1. So the point here will be 1 and minus 5. So try to use a certain value to try to understand this subject. And of course, it can be rotate clockwise. So you can just think about that. Rotate clockwise 90 degrees is anti-clockwise 270. Rotate clockwise 180 is the same as anti-clockwise 180 degrees. Clockwise 270, that means anti-clockwise 90 degrees. Alright, so let's try to solve some problems like this one. We want to find the area of different figures. For example, here is the area of triangle OAM and triangle OBN. Then you can find it like this. So because you know the coordinate of A, so you can find that the coordinate of M, it will be 5 and 0. So area of triangle OAM is actually OM times MA over 2. So OM is, you know that is 5, MA is 8 divided by 2. Then altogether, it is 20 square units. And also, if you want to find the area of triangle OBN, similarly, you can say that, oh, I know that the coordinate of n is 3 and 0. So area of triangle OBN is like this, ON times MB over 2. So you can get is 3 times 10 over 2, which is 15 square units. So you once found these two, and then you try to find the area of quadrilateral ABNM. So ABNM, you would need to know is that this one is AM plus the length of BN times the length of NM, and then divided by 2. So what you get is, you can write it here. This is the length is 8 and 10, and this one is actually 2. So it is 8, 10 plus 8 times 2 over 2, then you can get is 18 square units. And part C, finally, you want to find the total area. So you try the area of triangle OAB. So you use the part B, the answer of part A, you're adding them together, and then you try to think about, should I minus something? So what it means, you can think that this is triangle OBN, this is triangle OAM, and this is what you have found for the quadrilateral ABNM. So you can add this one to this one, and then minus this one. So the part C, the area of triangle OAB equals to area of triangle OBN plus area of ABNM, and then minus area of triangle OAM. So altogether, it is like this, 15 plus 18 minus 20. Then you can get is 13 square units. So how about some rotation? So you see this point is rotated clockwise, and then anti-clockwise about the origin through to this 90 degree to B and C respectively. So originally, you can think about it. So 3 and 4, where is it? It should be something like this, 3 and 4. Say this is the point A. And then if this is rotated clockwise, then you can get somewhere like this here. So this is 3 and 4. And if you want to find the coordinate of that, first of all, you can write down 4 and 3. They must be interchanged. And then for this is the fourth quadrant, that means the y coordinate will be -1. So the coordinate of B is actually 4 and -3. And for coordinate of C, you can think about it is on the other way around, or you can think it is opposite of B. If you know it is opposite of B, so these two have the same distance, and the values here, they are having the same value for x coordinate and y coordinate, but the numerical value only. So this is -4 and 3. You need to think about it. It's second quadrant. X coordinate is negative, and the y coordinate will be positive. So C is actually -4 and 3. And then how about part B? Part B, you need to find the area of triangle ABC. So triangle ABC is actually like this. You can see BC, BC is actually can be the base. And then OA here is 90 degrees. So you need to find the distance of OA and find the distance of BC. And then times OA over 2. That will be the area. So how about the area? BC, you need to use the distance formula. So x1 minus h2, then bracket square, and then plus y1 minus y2 bracket square, and then take the square root. That would be the length of BC. But of course, you know that it is actually the same as OA. So you can find the distance of OA first. Say if OA is 3 square plus 4 square, and then take the square root. OA is 5 units. So over 2. That means the BC actually is 2 times OA. Because OA, OB, OC are the same. So you don't need to write it in this way. You can just say that it is 10 times 5 over 2. So that's why this is 25 square units. And one more problem here, you have to think about rotation. So in this case, you need to think about how anti-clockwise 90 degrees right down, and then it's a reflection of the image. So think about it. What would it be? So if this is originally negative 3 and 4, you may say that A originally is like this here, negative 3 and 4. And then rotate anti-clockwise 90 degrees. That means if this is 90 degrees, it should be getting somewhere like this. That would be A prime. And the B, the coordinate of B is 9 and negative 9. That was originally here for B. And this is reflected with respect to the x-axis. That means it moves like this. And here the distance is 9. So you can get B prime. So that's why at the end, you know that for part A, for A prime, the value will be 4 and 3 first, and then both of them are negative, like this, because it's in the third quadrant. And then for B prime, so the x coordinate is 9, y coordinate will also be 9, like this. So part B, how to prove that AB is perpendicular to A prime, B prime. You know all the slope of this. So you find the slope of AB. Then it is, let's say, minus 9 minus 4, and then 9 minus negative 3. Then what you get is negative 13 over 12. And then you find the slope of A prime, B prime using the similar method. 9 minus negative 3, and then 9 minus negative 4. Then it is 12 over 13. So you say that slope of these two multiplying together is minus 13 over 12 times 12 over 13 is minus 1. Therefore, AB is perpendicular to A prime, B prime. So one MC question here. So it's point A is rotated anti-clockwise 270 degrees. Always look at it. And then it translates downward to 6 units to C. Okay, so this is then the coordinate of C is like this, find back what A is. So we can go through it backward. Originally, C is a point like this, 3 and 2 is C. But B is translated downward by 6 units to become C. So this is 6 units. Then this is the coordinate of B. That would be 3 and 8 for coordinate of B. And the next step is that A rotates anti-clockwise 270 degrees will become B. So you think about it, if there is a point like this, originally it should be, because this is rotated anti-clockwise 270 degrees, I would say that A is over here. Is it correct? No. Why it is not? Because if A is here, then rotating 270 degrees, it is clockwise. So you can try it, you know that, oh, it should be over here. This one is A rotated anti-clockwise 270 degrees to become B. And you know that the numerical value becomes 8 and 3. And which one is a minus? Then because it is in the second quadrant, so the x coordinate will be a negative value. So this is the answer will be A.